Ever contemplated the underlying mechanism of a car engine? It's a fascinating world of physics, mechanics, and chemistry, all working seamlessly together. Nestled beneath your car's hood is the heart of your vehicle, a dynamic, high-performance machine that turns the chemical energy in fuel into mechanical energy, setting your vehicle into motion. The process commences with a piston's movement within a cylindrical chamber. This triggers the spark plug, which sparks a tiny but intense fire, igniting the fuel-air mixture in the combustion chamber. The resulting hot gases from this combustion exert force on the piston, pushing it downward. This downward motion transfers to the crankshaft, which is intricately connected to your car's wheels through a series of gears and shafts. This is what sets your vehicle in motion, enabling you to traverse the open road. Each of these actions occurs intricately and rapidly, often blending into a single continuous operation that you barely notice. The gentle humming sound from under the hood is the symphony of these multiple parts working together in perfect harmony, creating a rhythm that is as predictable as it is powerful. Understanding the complexities of car engines isn't a subject reserved solely for the mechanically inclined. Anyone possessing an inquisitive mind and a desire to comprehend the marvel beneath their vehicle's hood can grasp these concepts. Today we're going to unravel this fascinating mystery. A car engine, also known as an internal combustion engine, is an extraordinary piece of machinery. Its purpose, to transform energy forms, a mix of simplicity and complexity. It showcases human inventiveness and our quest for technological growth. The internal combustion engine has evolved significantly over centuries. It revolves around a simple concept: converting potential energy, usually from gasoline or diesel, into kinetic energy, the energy of motion. This change happens through various processes within the engine. Understanding its working requires a grasp of physics principles. The conservation of energy principle states that energy can't be created or destroyed, only transformed. This principle governs the engine's operation. Fuel's potential energy becomes heat via combustion. This heat causes an explosion, moving the engine's pistons. This motion generates mechanical energy, powering the vehicle's wheels and producing the force that drives it. This complex operation boils down to a single pivotal concept. It's all about the explosion. The process begins with the intake stroke. Inside the engine, the piston descends in the cylinder and the intake valve opens. A precisely balanced mix of fuel and air fills the cylinder, designed for optimum efficiency. This is the engine's preparation stage for the power about to be unleashed. Next is the compression stroke. The intake valve closes and the piston starts its journey back. The fuel-air mixture now gets compressed, enhancing the energy within. This compression amplifies the impending explosion. It's like squeezing a spring. The more compression, the more energy released when let go. This builds anticipation for the main event. Then we have the power stroke, the star of the show. A spark ignites the compressed fuel-air mixture, causing an explosion. The force of it pushes the piston down, creating the power that propels your car. This is the climax, where fuel transforms into mechanical power, a testament to human innovation. We finally arrive at the exhaust stroke, the final act. After the power stroke, the exhaust valve opens. As the piston ascends, it dispels the used-up gases, making way for the next cycle. This is the engine's way of cleaning up after itself, always ready for the next round of intake, compression, power, and exhaust. This four-stroke process repeats itself over and over, thousands of times per minute. It's a dance of mechanical precision and thermal dynamics, a powerful ballet happening under your car's hood whenever you turn the ignition key. Each cycle sees air and fuel drawn into the engine, condensed dramatically, then ignited. This releases an explosive amount of energy that propels your car. The remaining gases are expelled, paving the way for the next cycle. It's a remarkable feat of engineering, a tribute to inventive minds. It's the perpetual cycle of intake, compression, power, and exhaust that keeps your car moving, mile after mile. In conclusion, the car engine operates on a simple yet potent principle. It draws fuel, and air, prepares them for ignition, ignites the mix, and expels the used gases. This continuous cycle propels it's more than just metal. It's a diligent machine converting fuel into power. Grasping how a car engine functions not only quenches curiosity, but also intensifies our respect for contemporary engineering marvels. Remember, it's not just a chunk of metal, it's a machine. tirelessly converting fuel into power.